In-class activity 18A, circles and rates of change. If the radius of an earthquake's S wave increases at a constant rate of 2.1 miles per second, do you think that the circumference will also increase at a constant rate? Will the area enclosed by the wave increase at a constant rate? Let me turn this on. There we go. And extend the page. Okay, so we could say something like, since the circumference C is equal to 2 pi r, the circumference is a multiple of radius. So the circumference might increase at a constant rate. However, but, since area is equal to pi r squared, the area may not increase at a constant rate. Let's go to the next screen. Objectives for the activity. You will understand the circumference of a circle whose radius is changing at a constant rate with respect to time will change at a constant rate. The area of a circle whose radius is changing at a constant rate with respect to time will not change at a constant rate. You will be able to determine the average rate of change of the circumference of a circle as a function of the average rate of change of the radius. Determine the average rate of change of the area of a circle as a function of the average rate of change of the radius. Determine the average rate of change of the volume of a disk as a function of the average rate of change of the radius. 2. In preview assignment 18A, you developed a model for the radius of an earthquake's S wave as a function of time, r equals 2.1 t. In this model, the radius r is measured in miles and time t is measured in seconds. Part A. Let R1 and R2 represent the radii of the S wave at times T1 and T2, respectively. If delta R is equal to R2 minus R1, represents the difference between the two radii, and delta T equals T2 minus T1 represents the difference between the corresponding times, what does the quantity delta R over delta T represent? Include units in your description. Well, the quantity represents the rate at which the radius increases per unit of time. Since R is measured in miles and T is measured in seconds, delta R over delta T is measured in miles per second. So let's write some of that down. We could write this. Quantity represents the rate at which radius increases. That's per unit of time. Since R is measured in miles, we have T measured in seconds. Delta R over delta T is measured in miles per second. Next screen. Part B, it says determine the value of delta R over delta T. Well, we could write delta R over delta T is equal to 2.1 miles per second. 3, let C1 and C2 represent the circumferences of the S wave when its radii are R1 and R2 respectively. Also, let delta C equal C2 minus C1, that be the difference of two circumferences. Part A, express delta C in terms of delta R. Well, delta C is equal to 2 pi delta R. That was part A. Let's go to part B, which is there. Use your expression for delta C to determine a value for delta C over delta T, the average rate of change of circumference. So if we think about this, if divided by delta T, so we have delta C over delta T equals 2 pi delta R over delta T. .2 pi. Number 4, let A1 and A2 represent the areas enclosed by the S wave when its radii are R1 and R2 respectively. Also let delta A be A2 minus A1, and that's the difference between these two areas. Part A says express delta A in terms of delta R and use this expression to find an expression for delta A over delta T, which is the average rate of change of area. So we could take delta A over delta T and write it as 2.1 pi times R2 plus R1. Part B says, is delta A over delta T constant? Well, it's not constant. No. You could state this rate of change is not constant because it depends on the values R1 and R2. So as the radii increase, so does the average rate of change. Let me just write that here as the radii increase, the average rate of change. That's the end of this video. Thank you.